looking at, let's start with the square root. Okay, the square root graph. Now, all the things that we're going to be doing in this section are based on the transformation rules that we've already talked about, involving linear equations, quadratic equations, absolute value equations, any of the equations that we've already talked about. All the transformation rules apply for these too. Okay, so in looking at it, the general square root graph looks like this. It starts from the point 0, 0, and it extends up and to the right. And so if you look at a couple properties regarding this, so first, if we look at the left and right behavior of this graph. Okay, where does this graph go in the left? Does it fall, or does it get smaller and smaller? Does it go down to the left here? Does it go up to the left? No, it just stops, right? It stops at an endpoint. So we'll describe that as just having an endpoint at the left. What about the right behavior? Does this graph go up and to the right or down and to the right? Again, if we were tracing this graph, would our pen be moving up or down? Up. So it goes up and to the right, which means it rises to the right. Okay, the other couple things to pay careful attention to are the domain and range for this graph. Okay, so remember, domain is the x values. So if you were identifying the domain and range in interval notation, which is what you're going to be expected to do, okay, the domain starts at the lowest value for x. So what is the lowest value of x here? Lowest x value is 0. What's the highest x value? It continues until it reaches no limit. So it's infinity, right? Well, you can never have the grouping symbol at infinity is always a parentheses. Is 0 included in the set of numbers? Is it part of that graph? Yeah. So you'll have a bracket at 0. So your domain is going to be from 0 to infinity. Okay, what about the range? Range is the y values. What's the lowest y value in this graph? Also 0, and it extends all the way. What's the highest y value? Also infinity. 0 is included, infinity can never be included, and so you have the proper grouping symbols. Okay, so all of the different transformation rules that we've already talked about will apply here. We can have vertical shifting, we can have horizontal shifting, we can have reflection, we can have we can have stretching or shrinking, and so we can have all of those different transformations. And the one other thing to keep in mind is that your square root graph might not just be represented in the radical form. It could also be represented as a rational power. So x to the power of 1/2 is still a square root. It doesn't matter which of these forms it's in. Those are the exact same things. All right, let's take a look at the parent function for any of the x cubed type graphs. Okay, this is what just a generic x cubed graph looks like. I'm going to draw just has a little bit more of a turn in it, but so this is your generic x cubed graph. And so it also has some specific left and right behavior. As well as a specific domain and range. And so what do you see to the left? As we move to the left, does this graph go up or down? Again, as we trace it to the left, we are going down, so it falls or goes down to the left. What about the right behavior? It goes up or rises to the right. The domain, are there any restrictions on the values for x? The lowest value of x is negative infinity, highest value, positive infinity. So there's your domain, again in interval notation, all real numbers. Range the same way if you're looking at the y values. The lowest possible y value begins at negative infinity, extends all the way to positive infinity. And so those would be the basic properties of your cube root graph. Okay, and just like the square roots, you don't necessarily need the radical form. You could also have the rational power form, x to the power of 1/3. So be prepared to see either of those.